Hello everyone, welcome once again. Now we have an integral question over here. So we have the integral ranging from um, 0 to infinity, and then e exponent negative x squared dx, right? And then we have to solve the integral, evaluate the integral. So now if you look at the integral over here, using the normal way of solving it, integrating this straight away will look a bit complicated. So what we are going to use is that what we are going to do is that we are going to transfer the single integral into a double integral. So let's say we have the integral, right, of the whole of this, right? So let's transfer this into a into a double integral. So doing the double integral, then we have I squared, which is just the double of this, right? So it's just like you have the and then another one again, but then this time we'll just change the variable to something else and then solve, right? So we have this double integral, we put them together, then we have I squared being equal to, so the first one is just your infinity of 0 here, and then we have so since we have this and this also, right, we are just putting them together, but then we'll focus on this first. So we have the integral 0 infinity here, e exponent minus s squared dx here, right? And then we have what we are left with is this outside, so this also has to come outside, y squared, and then the y here. Right, now from here we are going to just put them together. So since they are their limits are the same, so 0 here, and then we have the same thing here, so we have e exponent negative s squared here, right? And then we have e exponent negative y squared here. So the first one is with respect to ds, and the second one is with respect to dy, right? Okay, so let's put them together. So we still have this 0, and then we have this, so we can have negative s squared here, then minus y squared here, then we have the x, and then the y. All right, so now what we are going to do from here is that since we have this and that, so let's put them in the brackets like this, right? And then we can quickly do some substitution here. But before we do the substitution, we have negative negative, let's bring them out. So we have s squared plus y squared, and then if you look at the exponents over there, you realize that it looks like the circle theorem, right? Circle theorem, where we have s squared plus y squared being equal to r squared, right? But this time we have negative multiplying through, so we can just make it look similar here. So by just putting negative on both sides, and then realize that this is just equal to that, so let's substitute that into it. Now immediately we start substitute that into it, then we are just going to get something similar to a polar coordinate, right? We are going to get a polar coordinate, so we can have e exponent negative r squared. Now we are just substitute that into it. Now the first one will be to respect to the r, and the second one will be respect to the theta. So now what we have done is to transfer this into a polar coordinate, right? Now in a polar coordinate, for the values of r, right, and theta, we have r ranging from 0, so r ranges from 0 to infinity, and then also theta in the first quadrant, theta ranges from ranges from 0 to pi over 2, right? But generally so let's put a range, not plus, a range, just a range. Now so that's in the first quadrant, but then theta generally ranges from 0 to 2 pi, right? But this one we are talking about the first quadrant over here, so theta will range from that. So doing that, which means that the limit has to change now. So now the limit for, so the first one is theta, so it will change from pi over 2 here, we have 0 here, right, for the first part. Then for r we have just the same thing, e exponent r squared, we have the r, and then also the theta. Now the limit has changed since we have just transport everything into a polar coordinate, so the limit will change. Now from here, what we can do is to go ahead and now integrate now. So we have this being equal to we have pi over 2 here, 0, right? Now integrating the whole of this, we are just going to have, so this comes down, 1 over 2 drops, right? Remember it's negative. Then we have e still exponent r squared, right? Now we did this with respect to r, so we can have theta 0, and then what is left is the theta out, right? Okay, now from here, what we are going to do is to so we'll further simplify that. So theta over 2 here, then we have 0 here. Now, so what we can do here is to, so let's do it this way. Our I squared, we are just going to bring the negative 1 over 2 outside. So let's just bring 1 over 2 outside. So 1 over 2 outside, and then we have the integral pi over 2, 0, and then what is left is just negative e exponent r squared, right? But then this time r is just theta, sorry, infinity squared, right, minus e, then we have 0 squared here, right? But remember, it's then the theta counts for this one, right? Sorry. And then from here we have 1 over 2 here, right, pi over 2, 0, and then we have over here minus e to the exponent, that this goes to 0, right? This goes to 0, so the whole of this right here, right, goes to 0, and what we have here is just negative. Now we have 0 here, so any number raised to the power 0 is just 1 left, and then we have the theta here, right? So we have I squared, so our I squared here is just going to be left with 1 over 2 pi over 2, 0 here, and then we are just left with 1, and then the theta, right? So we integrate this again, integrating a constant, we are just going to get our theta back. So it's just theta, right, with respect to pi over 2 here, and then 0, right? And then we are going to put that into it. So we have I squared, 1 over 2 outside, and then we have pi over 2 minus 0 here, right? And then pi over 2 minus 0 is just the pi over 2. So we have 1 over 2 here multiplied by pi over 2, and then we just have pi over 4. That is for I squared. But then we have to find the integral, not double integral. So since we have I squared being equal to pi over 4, right? Now to find just the integral but not the double integral, what we are going to do is to so let's put square root on both sides. Alright, this will cater for that, and then our integral here will now look like we have square root of pi over 2 here, and that will be the value of that will be the integral. So thank you very much for joining me in this section. I hope this section was helpful. If you are new here, please like, subscribe, and also hit the notification bell to be notified anytime we post a new video. Thank you very much, and I'll see you guys in another section.